Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. Differentiation, Lecture 2. P3 syllabus. Implicit functions. Implicit functions means the differential of a function with different operator. In this case, differentiation of y with respect to x. An important advice for me and for everyone, we must be well mannered. Explicit functions. Y is equal to f of x are called explicit functions. For example, y is equal to x square plus 5x, because in this equation y is given explicitly in terms of x. However, many functions cannot be expressed in this form. For example, this one. You cannot make y subject from this equation. This function is known as implicit function. So, implicit functions means when a function is given as an equation connecting both x and y, where y is not the subject, like this, it is called implicit function. In general, implicit means the differential of y with respect to x. Here is the rule of differentiation. To differentiate a function, we must have same operator. For example, in order to differentiate x cube, we must have dx here. If we have same operator, then we can easily differentiate the function like this. But if we have this thing, or if we have this thing, d upon dx y cube, we cannot differentiate this easily because the function and operator both are different. So to differentiate this function, we first need to convert this dx in the form of dy. We must have dy here. According to the rule of differentiation, we must have same operator here. So to differentiate this, we need to multiply this entire thing with dy upon dy so that we can bring dy here. So after multiplying this thing with dy upon dy, we just need to interchange these two. So when we will interchange these two, we will get this thing and this thing here. See, the function and operator both are same now. So we can easily differentiate this. So the differential of y power n with d upon y with respect to y is this, n minus 1, and the function y. And this is as it is. You have to copy this here. Finally, the differential of y power n with respect to x is n y n minus 1 times dy upon dx. So this is the way to differentiate implicit functions. See, this is the rule. We multiply the differential of y with dy upon dx like this in all the implicit functions. So this is here. I already have explained this here, but I'm again explaining this here. See, both are different, so we need to multiply this thing with dy upon dx. With dy upon dy. So we just need to interchange these two because we need dy here. So after interchanging these two, we have this thing. So see, the operator and function both are same. Now the differential of y with respect to dy is 1 and this dy upon dx is here. This is the way to differentiate this. That is why we have d upon dxy is 1 times dy upon dx. We simply write this as dy upon dx. We don't mention 1, but it's logic. The logic is this. The differential of y is 1 and this is dy upon dx. This is according to this. So if you have to differentiate just y, so the differential of y will be 1 and you need to multiply this with dy upon dx because this is implicit. I'm sorry. So when you have to differentiate y cube with respect to dx, you can differentiate this. You should differentiate y cube as 3y square but you must multiply. Remember, you have to multiply this differential with dy upon dx, because this is implicit. So every time you differentiate y with respect to x, you differentiate y and you multiply your answer with dy upon dx. See, this is implicit, because differential of y with respect to x is always implicit, because they both are different. When the functions are different, this relation is always known as implicit. Well, the differential of sine y cube will be cos y cube, differential of y cube will be 3y square, and you must multiply your answer with dy upon dx because of implicit functions. But here you don't need to multiply your answer with dy upon dx. Why? Because the function and operator both are same. When they both are same, you just leave your answer here. But when both are different, must multiply your answer with this operator, dy upon dx. This comes here and this comes here. More examples. So y cube will become 3y square and must multiply 3y square with dy upon dx. Sine y square will become cos y square will become 2y, and 2y must be multiplied by dy upon dx because this is implicit. E power y4, copy e power y4 here. Sorry, copy this here. Then y power 4, differential of y power 4 will be 4y cube. Must multiply this answer with dy upon dx because of this implicit thing. Next example, the differential, this is implicit, so first write the reciprocal of this. This is the way we differentiate ln. Then multiply this fraction with the differential of 1 plus y square, which is 2y, and now multiply this entire with dy upon dx. This is uv, this is u, and this is v. So according to uv rule, copy x square here, u here, and differential of ln y will be 1 upon y. Differential of y is 1, and must multiply this with dy upon dx because y is implicit. Now copy v and differentiate u. This is the simplified form. You can take the screenshot of this page if you want. These examples are very important. More examples. Again we have uv. This is u and this is v. So according to implicit uv rule, we first copy u and we differentiate y cube, and y cube is implicit. So it will become 3y square times dy upon dx. Now copy y cube, which is v, and differentiate u, which will become 2x. This is again uv. So copy u and differentiate y. It will become 1 times dy upon dx, or you can simply write dy upon dx if you want. Then copy v and differentiate u, which is 1. This is also uv. So this is simple function and this is implicit. This is a normal function e2x u. So this is u and this is v prime, this is v and this is u prime. So differential of tan y with respect to x will be sec square y. Differential of y will be 1, and multiply this with dy upon dx because of implicit function. Now copy v and differentiate e2x. e2x will become e2x times 2, and this is the simplified form of this. This is the routine question of P3. We need the expression of dy upon dx. This function is implicit and this is uv. So the first step is very important. We must multiply both sides by d upon dx. This is very important. Make sure you must multiply both sides with d upon dx. If you won't do this step, you will lose 1 mark. So by multiplying this equation with d upon dx on both sides, we have this. Now differential of x cube will be 3x square, but this is implicit. So this will become 3y square times dy upon dx. Now copy this 4 here to make uv simple, this rule simple. So according to uv rule, we need to copy u here and we need to differentiate y. It will become dy upon dx, v prime. Then copy v and differentiate u, which is x. Now you just need to make dy upon dx subject. You need to bring this here and you need to shift this on other side. Now take dy upon dx common, and this is the answer, dy upon dx, the expression of dy upon dx. These two steps are very important. The first step, multiplying both sides with dy upon dx, and then differentiate function very carefully. Make sure you must multiply the differential of 3y square with dy upon dx here, and the differential of y must be dy upon dx. And write this forth outside the bracket to make this rule simple. I'm sorry. Next example. This is the past paper question. The equation of a curve is this: implicit function. Find the equation of the tangent to the curve at this point. So first we need to find dy upon dx, and for that we need to multiply both sides with dy upon dx. This is the first step. Now differentiate this very carefully. This is uv. So this 2x will become 2. According to uv rule, you need to copy u here, and you need to differentiate ln x. This is 1 upon x. Now copy ln x and differentiate y, which will become dy upon dx. And 4y will become 4 dy upon dx. Now you need to substitute this point 1 comma half here, or maybe here. You have option, you can substitute either this here or here. So when you will substitute 1 comma half into this equation, like y is half, x is 1, ln 1, you'll get this equation. And when you will simplify this, you'll get this value of gradient, 5 upon 8. Equation of tangent is very simple. It is y minus y1 mx minus x1. That's the final answer. You can take the screenshot of the solution if you want. Next question. This is the next example. This is uv and this is also uv. So make sure you use uv rule very carefully. So according to uv rule, see, we are applying uv rule here first. So copy x here according to uv rule, u here, and differentiate sine y. This is implicit. So the differential of sine y will be cos y times dy upon dx. Must multiply differential of, cos y with dy upon dx, because this is implicit y with respect to x. Now copy sine y, which is v, and differentiate u, which is x, so it will become 1. So this is the uv rule here. Let me repeat it. According to uv rule, copy u here and differentiate v. The differential of sine y is cos y times dy upon dx, and then copy v and differentiate x, which is 1. Now use uv rule here. According to uv rule, copy this y here and differentiate cos x, which is minus sine x. Then do the opposite. Copy cos x here and differentiate y, which will become dy upon dx. And this is the simplified form of this. And this is the uv rule. You can take the screenshot of this solution if you want. Next example. This is June 19, paper 31, question 3. Find dy upon dx of this at this number, at this point. So first, you should multiply both sides by d upon dx. Multiplying both sides with d upon dx, and then be careful while differentiating this and this. So x cube will become 3x square. Write this 3 outside the bracket so that you can easily do uv thing here. So according to uv rule, copy u here and differentiate y square. The differential of y square will be 2y times dy upon dx. Must multiply 2y with y upon dx because this is implicit. And the differential of y cube will be minus 3y, let me first complete uv. So according to uv rule, copy u and differentiate y square, it will become 2y dy upon dx. Now copy v according to uv rule, so y square is here and the differential of x is 1. So this is uv rule. Now you have to differentiate y cube. It will become minus 3y square dy upon dx. Must multiply this with dy upon dx. And the differential of 1 is 0. Now you don't need to simplify this. You just need to substitute 1 comma 3 straight away here, because they didn't ask the expression of dy upon dx. They just asked find the numerical value of gradient at this point. So you don't need to simplify this. So by substituting 1 comma 3 into this equation, we have this, and this is the numerical value of gradient. This is a composite implicit. You have to write this 4 here, then copy this function here, make this power coefficient, subtract this power by 1, differentiate sin y, it will become cos y. Differential of y is 1, and must multiply this with dy upon dx, because this function is implicit. That's the final answer. Another past paper question. The question is, find the gradient at this point. So this is uv and this is also uv. Both we have uv twice here. So you can either write 3 outside the bracket, or you can use this as u. You can take this as u and this as v. So this is u according to uv rule. Let me first label this. This is u and this is v prime. This is v and this is u prime. This entire is v prime. This is u prime and this is v. So copy u and differentiate y dy upon dx, then copy v. And what is v? V is y cube. V is y, and differentiate this u. So according to uv rule, we have u here and differential of y is dy upon dx. Then we have to copy v. This is v, and this is u prime. See, u prime is 6e2x and v is here. Now according to uv rule, here copy u and differentiate y cube, which will become 3y square dy upon dx. Then differentiate ex and copy v. So this is uv rule. Now substitute this point here straight away and get this numerical value of gradient. Differentiation, these 2 steps are very important. Do these 2 steps very carefully. Another question of implicit function. Well, first multiplying both sides with d upon dx, we have this equation, and we need the coordinates of maximum point. This is uv, this is implicit. So copy this here. This is uv. See, this is u, this x is u, and this is v prime, 2y dy upon dx. This is v and this is u prime. And ay square will become 2ay dy upon dx, and this will become 6ax. Now straight away substitute dy upon dx 0, because we are working for the x coordinate of maximum point. So when we will substitute this to 0, we'll get this thing. Now make y square subject and say this is equation number 2. Call it equation number 2 or name it as equation 2. This is equation number 1. By solving these two equations simultaneously, we can easily get the x coordinate. We just need to substitute y square here and here. So when we will substitute y square here and here, we will get this equation. By simplifying this equation, we can get the x value of m under root 3a. This is the final answer. You can take the screenshot of this solution if you want. Well, the next topic is parametric equations. Parametric equation means two equations connecting x and y, and they both depend on the third variable, either theta or t. So this is an example of a parametric equation, and this is the formula of the gradient of parametric equations. An important